Give it up for Raj and the panel.
Hi, everyone. Can you hear me? Can you hear me? All right. Excellent. All right. Welcome, everyone. I'm really excited to be here. So we have three amazing panelists, and I'm going to start by letting them talk about themselves a little bit and their data science journey. So Aarthi, tell us a little bit about yourself, what you do, and also a little bit about your journey in data science, machine learning.
Note to myself, never sit next to the panelist or you'll be the first one to answer every question. Hi, my name is Aarthi, and I lead the product in machine learning and AI for Target. We have a research center in Sunnyvale. I have a background in computer science and engineering. Am I too loud? You guys are okay?
Okay.
So I have a background in computer science and engineering. I was in product management for fintech over 15 years and transitioned those data skills thanks to Andrew Ng's course. We didn't have Springboard then. Into retail, ML, and AI. So I lead the personalization team for Target. It involves both the data science experiences, algorithms on the back end, as well as the user design experiences. So part of me wants to be in the other panel as well. It's great to be here. I was thinking about my Saturday, how to spend it effectively. And so this seems so inspiring after seeing Gautam speak.
All right. Joe.
Hi, everyone. My name is Joe. I'm the head of data science at a company called Hustle. Hustle's a peer-to-peer text messaging platform. If you've got a text message about the SF mayoral race or the upcoming midterms, you're welcome. My journey, I did a very computer science undergrad, and then I kind of walked away from all that for a long time. Studied neuroscience, was in academia, and I actually did a bootcamp called Insight Data Science. I think this was prior to Springboard as well, and that got me my first gig, which was at a music company called Beats Music, and it was just amazing, the idea that like that could be your job. You know, looking at data related to music was amazing. And then I worked at Reddit for a long time. I set up the data science team there, and I actually hired Raj, which is a Springboard alumni. And yeah, I left Reddit to join Hustle, and you know, the teams that I tend to lead, you know, there's nothing better than a data scientist who can do a bit of back-end work. There's nothing better than someone who can do a bit of back-end work and do a bit of front-end work. So I like to kind of create teams that can use data science to build products, and you know, we use a lot of machine learning as well. We're just getting started at Hustle, so I'm excited actually to hear from you two today. But that's my journey so far.
Wonderful. Rajiv.
Hi, guys. Joe, it's the first time we've met, but I already feel like we share so much in common. Like, you know, I had a Y Combinator company like Reddit. I do front end, back end. I can do JavaScript, though I run the machine learning team at InMobi, which is a mobile advertising company. My own trajectory into the space has been over a long time. I was at McKinsey, and then I spent some time, I did a PhD in physics, so that's a lot of statistics, as you would realize. And then worked in a couple of startups in the Bay Area, did a startup of my own. I've been at InMobi for the last 6 years, setting up the marketplace and data science functions, and it's just a great place to be at, with to be working with so much data in this day and age.
All right, so we'll spare Aarthi the next questioning. So let's start with you, Rajiv. The next question. Tell us about a really exciting or interesting project at work that you've either worked on recently or you're currently working on, and why you're so excited about it.
Absolutely. I think the most exciting forms of machine learning data science is when it doesn't fit the mold. Right? Like, I've always struggled with this notion of data science as it's described at Kaggle, and you're just taking a data set off of Kaggle and building a model to fit that and tuning some parameters. I think that is too idealistic. That world does not exist. Like, life does not give you data sets, right? You have to create your own data sets. You have to figure out what's wrong with it, and there's so much work you need to do to get it into a form that's presented at Kaggle. So at work, we run over 5 billion auctions a day, and each auction we run in 100 milliseconds or less. And for each of those auctions, we have to make decisions like, do we want to run the auction, who participates, who wins, at what price, and things like that. And recently, I've been working on AI system which learns how to price these auctions. And the way there are many different definitions for AI and machine learning. The particular context I'm using it in is that it doesn't know the rules, and it figures out the rules, it explores, and then it keeps testing and improving. Just the noise is so much, and the scale is so much, and it's just been very, very exciting to be working on that.
Wonderful. Yeah.
That does sound cool. At Reddit, it was like everything was a huge amount of volume, distributed problem. So you ended up trying to do complex things and then bring them back to very simple methods so you could actually get them to work in production. We don't have the same volume at Hustle, which is really, really exciting if you're someone who wants to try a lot of techniques. So Hustle is very unique because we have a lot of SMS messages, and we have a lot of our customers tag those messages. So we have a very, very interesting data set. And we're moving into a world where we're using a lot of very standard neural network approaches to help optimize and help people have the right conversation at the right time about quite difficult subjects when you think about politics in America right now. So for me, it was probably the first time I've ever put a neural network into an actual feature that was required it. Every other time it was I'm doing this because I want to have a neural network in there. It was the first time I was I don't think this could be achieved without this technology. So that was pretty cool.
It's really exciting to see you speak. It feels like I'm talking to my data science team because it's they're always reading all these papers and doing some amazing stuff. Like just this next week for a demo, they're doing their own LED lights and planning it with showing how a simple neural network works. And my brain on the business side goes, how am I going to make sense of this, and what is the ROI on this? So the biggest thing I have, I feel proud about in my day job is essentially being the bridge between the business and the algorithms, and trying to scale those to production. Because if you really think about the types of algorithms and papers you have, it's awesome to see it working. But really, what is the optimization potential on a retail industry or healthcare and so on? So that's what I'm really excited about, bringing that customer journey in, bringing that design thinking into data science so that they also understand our customer pain points while building the right solutions. That's something I'm excited about and going through the product journey. And just outside, I'm also thinking about how can AI help the community, and looking at options where something like a crime prediction. I have this idea for a company called Saved Life, and my co-founders are here. And what we are trying to do is take all the noise which is there and try to make predictions about crime and so on. That's, yeah.
I really like what you just said about bringing design thinking to data science, because that's making me think this is something we need to be teaching our Springboard students a little bit more of, because I think that's something that I see coming in the future, like the whole customer thinking and design in data science.
And it's a tough problem because data science is the first time research is really applied to business in a way it's not applied before. So how do you, because earlier research was dedicated to the NASA types and then it'll come and get commercialized, right? Whereas now it's an integral part of every company. So how do you make the brainchild work with the existing operations of a company?
Yeah. Well, speaking of trends and new things coming up in data science, so this is the future of machine learning talk, so let's dive into that. Our audience would be probably very interested in knowing what are some of the new upcoming tools, trends, technologies that you see in the field in the next couple of years. So would love to hear something from you.
So I would say, like broadly, we've seen about 25 billion investment in AI as a sector, and it's expected to have trillions, like in by 2030 is the impact it's expected to have. There are broad themes, obviously, like you're using more of voice instead of using your text and typing. That's kind of one of the themes. Alexa, Google Home. If you see your kids interacting with your phone, the first thing they do is talk to Siri, right? That's, yeah. And so that'll be, voice will be one theme. Autonomous vehicles, we will see that within our time. It'll be a reality, maybe not level 5, but it will surely be close to that in terms of achieving that. And in other areas are with visual recognition, security, image recognition with the heavy investments. That's also another area which I see used in healthcare as well as in security. In terms of the tools, I think AI, you still need a level of expertise, which is unfortunate right now. Like it's, even with TensorFlows and AWS and integration into all these systems, I can't have my regular day, like engineers, back-end engineers, as you call it, start optimizing for every line of code. So there are systems, platforms in the startup space, which are simplifying the whole AI platform, right from data prep to the algorithms, because like I mentioned, there are only like 15 or 60 handful algorithms that you can use for production with an ROI. There are hundreds of thousands of other algorithms, but the ones with an ROI which can be dragged and dropped easily is that. So there are platforms which are being built which help make optimization a part of your every line of code that you write. So it makes it simply for any type of engineer, not that you need to have a PhD or like the engineering background to do data science.
Wonderful. What are you seeing, Joe?
Yeah, I think that was a great overview, and just talking about there's just so many more APIs that abstract a lot of complexity, and I don't think about it in terms of back-end engineers becoming data scientists. I kind of think about it the other way around. Like I want my data scientists to be impacting the product, and the tools that are coming online that like let you go very simply from, hey, I'm going to train, I'm going to maybe like do an A/B test, I'm going to put it into production, and I'm going to come back and examine drift. Those frameworks, whether they're open source, there's a couple, Clipper.ai is very good, and there's a couple of like commercial products, Domino Data Labs. I think everybody knows that Google are going to kind of come hard at AWS SageMaker with whatever they release. Those things are really, they're gonna help data scientists, if data scientists know them, really just move faster and shorten the time frame from like, I wonder, is this possible given the data set, to let's test it in production. So any framework that like shortens that time is exciting because it just gets you more data on your idea much faster.
Fantastic. I learned so much right there. Just to add to that, the couple of big trends that I'm seeing, at least from a more practical point of view, are beginning to impact how my team and I look at the world. One is just explainability, right? I think there's a whole bunch, there's a lot of work being done on explaining models. Why did it come up with a particular prediction? Like, if you look up Lime and things like that, you'll see where people are trying to explain models locally and trying to test the output of a model and the biases of a model and things like that. So that's kind of giving visibility into the inner workings of a model and removing the black box aspect of it. And I think that's a big area of work, and that will just help models work better in production and in real life. The second bit is kind of related to it, which is everything to do with machine learning operations, and I think both the other panelists alluded to it as well, which is what does it take to really make a machine learning model a part of a production system? Because there are many things that happen, like machine learning systems are not necessarily engineering systems in terms of having predictable responses, the same predictable response every single time. It can have funny outputs, and the underlying data can change, underlying systems can change, the way features are captured can change. And that entire part is complete greenfield in terms of how do you make these machines work and these systems work in production for over a longer period of time. So that's the two big trends: explainability, machine learning operations. A couple of tools that I think are beginning to get very exciting is everything to do with hyperparameter testing, right? Like I think people underestimate how important it is. Like every single time you put a model in production, you need to tune for hyperparameters, and that takes a lot of time. It takes a lot of infrastructure and compute and things like that. So tools like Hyperband or population-based training that DeepMind has put out, fantastic stuff. Definitely important to get your hands dirty on. The other buzz that I'm hearing from the team is everything to do with PyTorch. And people are excited about it for the automatic differentiation and things like that. But again, it's also, people are talking about how much easier it is to model things in PyTorch. And again, just something good to know about and learn and try it out. But I just wanted to put that out there.
Yeah, I'll just make one final comment. It's something that I always think about. Every company has their unique data set, but like data is becoming very like uncommoditized in the way that it was maybe a few years ago. You could go to a company and say, "Hey, I want to buy this off you." Like that, those sort of exchanges are becoming less and less common. So, like, I think there's going to be somewhat of a reinvestment and a re-examination of like, okay, like, did we truly get everything we can out of this data set? Like, like people they want to really like understand, make sure that they feel happy that like this is truly optimized. And when people talk about all these models, like the input is the data, and I think anyone who works in a company on anything to do with data knows that like the integrity is an issue, QA is an issue, correctness is an issue. And it's funny because I think small startups like they just hope they get data collection right. There still isn't like this very strong approach to like, here's how you do it, here's the book, read the book will tell you how to do it. There's still a lot of ad hoc approach to collection, but it can be severely undermining if it goes wrong.
That's why there's a whole sector on that, right? Figure Eight, Crowdflower, they all do that data labeling. And then because you asked about tools, Data Robot is the one I think they allow you to see inside the black box. And then what I was talking about is tools which span horizontally, doing everything, so you don't have to go and do individual specializations. And there's a ton of investment in that space.
Wonderful. So for the audience, you'll have some time for Q&A at the end of the panel, I'll make sure. So just hold your questions after then. So I'm going to just throw out this question to the panel. So given the trends that you talked about, one concern that we get a lot from our prospective students at Springboard is that is the job of a data scientist going to become irrelevant in the next few years because there's so many of these automated like tools, commoditized tools coming up. What are your thoughts on that? And then if you think it's going to still be relevant, what will a job of a data scientist look like in, say, 3 to 5 years? I'll just let any of you take it.
Cool. So this is a great question, and just to be provocative, will data scientists become irrelevant? Yes, but that's going to be the data scientist of today, which is if you don't learn and don't keep upgrading your skills every 6 months, or or even faster than that, you're going to be irrelevant in a year or two, right? Like, so I think the one thing that you're signing on by entering the stream is like acknowledging that you'll need to constantly keep learning. And that's the fun part as well. I'm sure all of us love to learn new things. And the reason is that there's such a huge body of people coming together for this. There's so much combined learning happening. There's so much innovation happening, so much open source, new tools coming out, like everything that you dreamt of is like becoming available like as an import function like within 2 months. So I just think that just know, like if you and I have this tendency too, which is just to stick to the few algorithms which work well for me, and if you just get stuck in that comfort zone, you'll miss out all the new stuff that's coming out which can do things faster, better than you could ever do with your old algorithms. So to your point, I think yes, if you're not upgrading your skills constantly, and that's just part of the job, you will become irrelevant. But as a whole, I think the promise is fantastic. The problem space is growing so fast. There's so many topics. I just think if you are a constant learner and someone who enjoys this, there's no danger at all of you getting replaced by a machine or anything.
Do you want to go?
Yeah, I agree with that. Like the stuff I learned 6 or 7 years ago is like incredibly irrelevant right now. I think the one thing I would say is that data science is like data is so pervasive in every business now that if it's a case of in 5 years' time, you look and you're like, I don't want to reinvest my time in like learning new skills or learning new technologies. I think we're going to see a real graduation of a lot of data scientists into other parts of the business. Some of the best PMs I know are data scientists or were data scientists. You see a lot of data teams becoming revenue channel owners. You see a lot of data teams really like starting to own core product features instead of being, in some senses, like sideline ancillary groups. So I think there'll be a deepening of like data throughout like business and org structures, and that'll come with an opportunity to like take on different roles. But I totally echo, yeah, like you guys are in the right place. You've got a great community and a network to keep you guys updated on, changes in the field and things you should think about. And it can be hard to maintain that learning pace. So sometimes you might end up on a team that doesn't really invest in that, and that can be very detrimental. If you can find teams who believe or have that same belief, they'll give you the space for that as well.
I mean, for me, I think your jobs are still stay safe unless people like me who are PMs start doing the import functions ourselves. So it's going to, it goes back to simplification of the platform for me. The analogy I think about is a tree. So when we started data science like 5-10 years ago, you guys were the seeds and with different algorithms, writing papers on identifying cats and dogs and going from that to actual business applications. So the tree has kind of grown now, and when it starts bearing fruit, people like anybody, like PMs, engineers, can start picking those standard algorithms that Rajiv was talking about and start using that in their day-to-day, right? Then what do you as the expert data scientist do? Then you have to plant another tea and try to do hybrid, or you have to find another problem space, which is with applied AI, like with AVs or with robotics, and learn about that field, right? So the onus is on everybody to learn, like the theme here as we see for Springboard is apt about learning. But with data science, you have to be even more deeper into the roots, either optimize it till you get the optimal benefit, the base rate, or for your algorithm. But beyond that, move on to the next tree and try to create hybrid products, if that makes sense.
Yeah, wonderful. One thing I would like to add is one answer I have for students when they ask this question is also that even though it seems to us that data scientists are everywhere and data is being used everywhere, there's still the majority of companies in the world that are not really exploiting their data. They have not even gotten started with like basic stuff. And there is a huge amount of opportunity out there that's still out there and to be exploited.
And there was actually a McKinsey survey about that. Only 20% of the companies in the world have scaled and data science product to production. And of the companies who have scaled, they're seeing a return on investment in that. Like at least 50% of them are seeing top lines improve. And so yes, there's absolutely opportunity to get everybody on the journey. But if you want to be cutting edge, you can surely learn other things.
Yeah. All right, let's move to a couple of fun questions. So we hear a lot of hype in the media about the future of AI and machine learning. On one side, there's like, oh, we're going to have self-driving and self-flying cars and everything will be wonderful. On the other hand, there'll be Skynet and robots will kill us all. So what, as people in data science and people in machine learning and AI who are looking at these technologies, what do you think about all this hype? Like, where's the truth and what's the hype here?
I believe in singularity. I think there is a limit to what we are feeding in as humans, and you assume that most people in the world are good, and then the data which we feed in, the sample data, the training data, doesn't have the bias, but obviously there is bias. And if there is an evil guy, he's going to create Skynet. And we do have, we had a military robot in 2012 in Japan called Kuratas. And so Elon Musk and Alphabet's Mustafa started this forum for banning, and they're appealing to the UN to ban autonomous weapons. I think we should not just give the onus on CEOs anymore, and we as a community should also organize and take control of these things, because otherwise you'll have like the Sheryl Sandbergs and Jack Dorsey's answering to the questions when it's our data which we have we have spread out in the internet, right? So we as a community have to have some rules and guidelines to protect that as well. And the leaders are doing that. Google's Deep Brain also has an ethics committee to prevent things like this. I do believe it's possible because it's garbage in, garbage out.
Yeah, I think I think you want to be very, very optimistic about the future, but also very, very pragmatic about the fact that if we do believe AI is a transformative technology, I think there's very few instances in our history that transformative technologies were not misused or did not end up in a situation where they hurt people. So it's highly improbable that there will not be misuse. And I think that the question then is like, how can we move forward while it's trying to mitigate that to the strongest degree possible? And I would echo your statements. I think that if you work at a company and you're using data to do something, like, is that a good thing? Like, it's sometimes it can be as simple as that. And I think making it more complex than that right now avoids kind of correction in the short term and hopes for a very long-term adjustment, which I just don't know if that's more likely. I just know that I can decide not to work somewhere. I can decide not to do something. And I would encourage folks to like operate with that conscience.
I couldn't agree more with both of you. For me, this is a very exciting topic, which is, can machines take over the world or not, right? And for me, like, my goosebump raising kind of moment happened when I saw the DeepMind Atari paper, where, like, the same program, which knew nothing about the game, played like 15 games, and like within a day learned how to play like 7 of them better than any human. And all it was given was a screen and some controls, and it would figure out like, oh, this is how I play Space Invader, this is how I play Pong, and things like that. And then they used the same algorithm to do AlphaGo, and then they used it for doing Google Power Management, whatever, right? And so these generalized reinforcement learning kind of algorithms have a lot of potential, and like, they can explore the space. That's on one side. The other side is the topics that my co-panelists were talking about, in terms of saying so much of our data is out there, the data is getting very rapidly structured outside, and all kinds of data is becoming available. And so arguably systems could come up which could use this data to become strong and figure out how to game these systems, game the population. But I guess the only part that will save us a bit is just the data density, right? Like the kind of density that is required to make these generalized like reinforcement learning systems work really well is very high. Like, it's the kind of data you would generate in 2,000 years maybe, or 5,000 years. So what that means is that you might not get like a sentient being which just controls everything. But what you might get is, for small pockets, very effective tools to game things like the elections, like propaganda and things like that. And to your point, Joe, it's like that's where misuse comes in. Like, and all transformative technologies have led to transfer of control, transfer of power, and just because machine learning AI is so leveraged, you should expect that the transfer of power will happen to a smaller group of people or smaller set of people, and which is the kind of things that we're seeing right now. And that's where it has bigger questions, like in terms of, will these tools end up becoming control devices for control instruments for a small group of people across the population? Will it take away our freedoms? Will it take away our ways of seeing the world? And maybe these mechanisms existed before, but maybe they're not so efficient before. But that's the big questions for us in terms of, how do we bring in more oversight? How do we make sure that neutralize some of this.
Wonderful. So I read, I don't know if any of you guys caught this, but I read this amazing Medium article a couple of days ago by Francois Chollet from Google, who's like a deep learning expert. And he had a lot of interesting thoughts about how machine learning and AI is now currently, especially when used in the context of social media, reinforces our current biases. So it dictates who we see, what we read, who we connect with, and so on. And there are other concerns about ethics and biases around machine learning. For example, crime prediction tools are one of them, because one of the critiques of those is that they reinforce existing social biases around who commits crimes. So in the next couple of years, do you see like controls on these kinds of biases or regulations, again, around AI and machine learning coming up or people kind of self-regulating around these?
So I could start on that. So a couple of weeks ago, I was in the audience and the CTO of Pinterest was talking, and he made a point which was very profound. And he has a thick Russian accent or somewhere from that part of the world. And he said, all machine learning models have bias, right? So his basic point is, by design, every single model that you learned, whether it be a linear regression or whether it be a deep learning model, is designed to detect bias. Right? That's how it does its job, because it says A wants this, B wants that. That's bias, right? You cannot remove bias from a machine learning model by definition, right? You just can't do it, right? That's the first part. The second part is that, like Aarthi mentioned earlier, a lot of the bias is in the data, right? Like it's not in the model. The model is just a mirror of our decision-making processes over a period of time, and maybe slightly more sophisticated in terms of being able to handle many more features. So what the biases that we're uncovering now, it's almost like doing a bit of archaeology into our decision-making processes, and we're figuring out, you know what, maybe there was a bias in the way we were like arresting suspects. Maybe there was a bias in the way we were promoting people. And that's now coming to front because we're looking at those data, which is actually very promising for us because we can go back and fix all of those things. And what we have really gotten ourselves is a bunch of tools to uncover these biases and actually act on them. The third part, which is very important, is the fact that the times have changed. We live in a different kind of world now. We live in the postmodern, post-truth kind of world, where different people can think differently about the same topic. And we're talking about the world of alternate facts, where different perceptions can be made about the same event. And so that's where having neutral models which can relay the truth or which can provide an objective viewpoint become very important, like in terms of being, like our brains are not geared to handle a lot of the features of like big data or highly featured data. And maybe models can help us do that, like in terms of being able to process huge volumes of data, the rich reality around us in much more real, nuanced ways. And I think that's where there's a big role for machine learning to eliminate bias.
Yeah, that is quite profound to think every machine learning model operates because of bias. I think, something I think about is that if you take that fact further and you say that, like, listen, humans also operate with bias, there isn't really a data set out there that does not have some issue with it, maybe at the very, very low level of chemistry and physics. But I think what I would say is, I subscribe to this idea of being a good internet citizen. Like, if you care about what you do on the internet, and you don't want to be tracked, delete your cookies, install an ad blocker, use the tools available, like, educate yourselves. And I think there will be a burgeoning kind of field of like, hey, if you do not want to be part of the machinery that builds this bias, or like is in somehow you are operated on by the bias of these models, like, become a good data science citizen, and either small acts of civil disobedience to stop yourself being tracked on video, to stop yourself being tracked on your phone. Like, all of those things undermine the concept that these algorithms can truthfully operate in the modern society. And I think you're going to see more and more of that.
Yeah, for me, it's I mean, I think it's interesting if you stop off tracking, all my recommendations will fail on target. So don't do that. But what I would say is one of the Andrew Ng students asked him like, why is the model only achieving optimal error? Like if once it goes past the human error, there's only very little optimization that can be achieved. And then one of the responses was interesting. They said because the human is feeding the training data and labeling the data, right? So we are teaching the computer, and so what we teach is what we're going to get back. And there's proof, I would actually say, like our divide in the country or divide in our political beliefs is because of, to some extent, what things we are being fed. So if you go and search for vegetarianism in YouTube, the next thing you'll get is vegan. That's the extreme form, right? So they do optimize so much. So there's methods like explore, exploit, where you're showing me vegetarianism and vegan. Is there value to show me something on the other side and give this neutral model that Joe talked about, right? Why? And there's a lot of research as well. I forget the name of the researchers, but it's essentially they put Republicans and Democrats, separated them and made them stay in extreme forms of like the progressive ones with more conservative and the liberal ones with extreme like tree hugging kind of liberal views, right? So then what happened after 10 days, they looked at both the people, they moved far right. The right people moved far right, and then the left moved far left. So the more you feed, that's what you become. You'll think it is, it's truth. So we are gifted with a good human brain, and I feel we rely on technology so much that we stop using it. Use these as aids and augments for data management and time management, but not trusting them fully, right? And I feel like with our future generation and screen time, it's going to become more and more difficult to have that common sense element. That's where I think we need to have that balance and not forget our humanizing effects. And there are organizations like Humans for AI, which has started it, where they're bringing in diversity. So you don't need to have only men data scientists. Have some women. They might get a different view. Have different ethnicities. They might get a different view on the training data, right? So promote that because it helps your training data as well. That's one thing. And I would also say, like, if you get one data set, now you're not limited to just your data warehouse data sets. You can augment it to third-party data and have even terrestrial data. So you can, there are companies which take satellite images and look for like patterns on deforestation. And so you combine that together, right? So you have ways to augment that and use it as a human human companion as opposed on just like fully reliant on that system.
Wonderful. All right, questions from the audience. All right, right here. In the interest of time, let's have just one panelist answer it.
Yeah, I have a very simple thumb rule that I try to use all the time, which is 10% exploration at random at least, right? Like, so which is like any machine learning system which is not randomly exploring will tend to find like, feedback into itself and finally like saturate up or down. So of course, there are much more nuances to this, but I find this simple thing actually helps remove a lot of the diseases of machine learning systems, which is in the explore, exploit thing that Aarthi was talking about. At least have 10% exploration, if not more.
You had a question over there?
Yeah, I think it's a great question, and it's a good idea to think that far ahead sometimes in a field that's changing so much. So what I would say is find a team who has more than one stakeholder across the business. So if you find a team that has only one stakeholder, that's the only point of view of the business that you'll see. So if you can find a data team that maybe works with sales, marketing, finance, maybe works a little bit with product, you'll have an opportunity and be exposed to much more kind of viewpoints of how the other parts of the business work. That can be hard in larger companies and maybe a little easier to achieve in smaller companies where like you're asked to wear a lot more hats. But I would definitely try and identify an opportunity where you'll have more than one stakeholder, and certainly more than one stakeholder in any single like org within the company, and you'll get to learn a lot of how they view the world and how they operate.
Great answer. Right there.
Okay. So just so I understand, you're asking if I capture data, how do I make machine learning eliminate bias from the data you capture? I might not be the right person to answer this, but let me give you my view, because I do believe there's value to have human in the loop. The problem where, for me, data science would fail is when you ignore the human, and I see it in many companies and businesses I've worked with where they feel like I am fighting the human and I'm going to do a better job. But I actually think, to your point, the question you had, there's a basic set of rules which the human doctor or a human business merchant or a category manager has about their category, which our machine learning algorithms are not there right out of the box to understand. So you want to understand that input and then start your training to be more optimized. And then you will probably become better than the human error and give them newer insights which they didn't know. So it's the same thing with like disease diagnosis and learning from our ancestors and our people who've done that before, right? So if you just rely on the machine, it's good to have some form of like that knowledge, whether you call it bias, but the system can reinforce itself, like trying to eliminate it, and you can actually ask the new generation whether it's relevant to them or not and give you positive feedback, right? There's explicit feedback on what you put to them. Example in YouTube, whether you're interested in this or not. So I do think there's value in human in the loop. Does anybody want to add?
Yeah, there's a couple of companies which I've been speaking to lately, which are doing this. It's a very interesting topic. One of them, what they do is they have solutions which look through your logs and extract features. So basically what you do then is go more to the raw side of signal, like whether you pick the event level data or like, the actual speech and stuff like that. And you have ways to cluster signals, find the same repetitive patterns and construct features ad hoc. And then you feed it to your models, which can figure out whether they make sense or not. Of course, like Aarthi said, you get a lot of data efficiency of like a few orders of magnitude by just having a human in the loop. But what you could benefit from with this method is just extracting new signals, which did not exist before.
All right, we're kind of out of time right now, but I hope you have, for those of you who have questions, I hope you find the panelists later in one of the networking slots and talk to them. Thank you so much for your time, everyone, and thank you for attending this. Let's give our panelists a big
Thank you, guys.